Hello, grade 12s. Welcome to my page. This is Maths and Science with Sita. I know I haven't been posting for the longest time. However, I'm back, and on this video, we are focusing on physical sciences paper 2, in particular acids and bases. Remember, this is question 7 of your question paper, but this video is going to be short because we are only looking at that part of the question where there's stoichiometry with 7 to 10 marks, and I'll just outline ways in which you can best approach this question to maximize your marks. So we have the reaction between excess magnesium hydroxide, MgOH2. It is a slightly soluble base. It is soluble, meaning whenever it is in water, it is going to dissociate into ions. This reaction, magnesium hydroxide and nitric acid, HNO3, occurs in an aqueous solution, meaning it is taking place in water, where it produces magnesium nitrate as a soluble salt and water according to the following balanced equation. So we have the equation of magnesium hydroxide, nitric acid, yielding magnesium nitrate and water. Then they further tell us that 0.05 decimeters cubed of this magnesium hydroxide solution has a concentration of 0.11 mole per decimeters cubed, and it is added to 0.025 decimeters cubed of 0.095 mole per decimeters cubed of nitric acid solution, and they want us to calculate the pH of the final solution, and this is worth 10 marks. Okay, so firstly, when they tell us that magnesium hydroxide is going to be in excess, or it is in excess, it means at the end of the reaction, we will still have some magnesium hydroxide together with the products because it is in excess. So we will still have some of this magnesium that is unreacted. We would have some unreacted magnesium hydroxide in the products. So it means when we want to tell the pH, we just want to know what would be the pH, because you'd still be having magnesium hydroxide, and already we have a picture of we have an expectation. If we will still have some of this unreacted magnesium hydroxide in the products, the solutions should somehow be what? Should be basic when the reaction is done, because we will still have some of the magnesium. So the first thing that I'm going to calculate the number of moles of magnesium hydroxide. This is the total that was initially added. So I will just name it total in a bracket, number of moles, total N for MgOH2. So this is what we initially placed in the reaction. So that is our 0.05 with the volume. Remember guys, I'm using C maybe to write the formula as well. C times V. I've just rearranged the concentration formula. Concentration for magnesium hydroxide is 0.115, and then the volume is 0.05. And that should be giving me 0.115 times 0.05. That gives me 0.00575. So those are the moles, the total moles of magnesium hydroxide that we initially placed. And if they tell us that magnesium hydroxide is the one that is in excess, then we can go and say it means nitric acid is a limiting reagent. I'm going to add that there. HNO3 is the limiting reactant, meaning it's the one that determines how much of the products are we forming. And it is the one that we can use to tell how much of the magnesium has reacted from the total. So then I'm going to find the number of moles for the limiting reagent, number of moles for HNO3, that would be 0,025 for the volume, and the concentration is 0,095. 0,025 times 0,095, and that gives me 0,00 1, 2, 3, 4, 5 2, 3, 8 more. So these are the number of moles for HNO3. Since it is the limiting reactant, it is the one that will tell us how much of the MgOH2 do we need, since it is in excess, to form the products. So from there, what I'm going to do, I will do the ratio for the magnesium MgOH2. So the ratio of MgOH2 to the ratio of the acid. This is for me to find how much of the nitric acid, how much of the magnesium hydroxide has reacted. So I do the ratio of MgOH2 is 2 HNO3. According to the reaction, 1 is to 2. So I have 1 is to 2. So since the number of moles of nitric acid are that, so I'll do, so now this is for me to find what? To find reacted base. Reacted MgOH2. Because out of the 0,00575 moles, only a portion of that has reacted, since this is in excess. So how much of this has reacted? I will be able to find it through the ratios to say how much of moles of MgOH are needed to completely react with the HNO3, which is the limiting reactant. So since this 1 is to 2, it means the number of moles NMgOH2, and remember this is the reacted moles. Reacted is going to be 0,00238 divided by 2. So that divided by 2, it gives me 0,00119 mole. So these are the reacted 0,00119 moles of the base reacted with the acid. So if the acid has taken only 0,00119 moles out of 0,00575 moles, how many am I left with in excess? So now I want excess mole for the base, for MgOH2. Remember, when you do excess, you take total minus what has reacted. So the total is 0,00575, 0,00575 minus, so this is number of moles in excess, minus 0,00119, and that gives me 0,00575 minus 0,00119, that gives me 0,00456 mole. So these are the moles of the base that were in excess, meaning when I said here that some of the MgOH will be found on the product, since it is in excess, it means that refers to this number. Now I know the moles, and then since we want pH, guys, remember pH, the formula for pH, just gonna slightly change my pen to black. pH is minus log H3O plus concentration. So it means I have to work with concentrations first. I'm going to take that excess number of moles of the base, convert it to concentration. So now I'm doing concentration of excess base equals number of moles over the volume. The number of moles is 0,00456. And then let us go to the volume. Remember now, this, guys, is happening. This is in the products. We said the base that is in excess, it will be found in the products. Meaning we would have added which two volumes? We would have added this volume and also that volume, because at the end of the day, when we have the products, the volume is 0,05 plus 0,025. So I'm going to add these two volumes, 0,05 plus 0,025. I hope you're still following, guys. The reason I'm adding these two volumes, it's because this is the excess base that is found in the products, and the products have resulted from when we reacted 0,025 volume of the acid and 0,05 volume of the base. So we just add them, and then we are able to see what is the concentration of the excess base in that volume, and that gives me 456 over 0,05 plus 0,025. So that gives me a volume of concentration of 0,0608 mole per decimeters cubed. This is the concentration of the excess base. Now, the excess base is MgOH2. They said it is soluble, and when they said soluble, I said it means that it is able to dissociate. It can dissolve nicely in an aqueous solution. Remember now, if I go back to the reactants there, the reaction to be specific, in the products, the products are in aqueous solution. I have water. I also have the salt dissolved in water. I also have the MgOH that was in excess dissolved in the very same amount of water. Then I have to say this is going to dissociate if it is in that water. When it dissociates, we break it into ions, and remember, when you break it into ions, you write Mg with its ion and OH. Already we know the ion, the charge, sorry, not with the ion but with the charge. The OH charge is minus, and then there Mg, it's in group 2. You can take the charge from there, it's 2 plus. Remember, when they combine, the charge could have went there, and then the negative could have went there. They swap. So then we balance the OH. We have 2 of them. I put 2. Now this is the dissociation. On the acids and bases chapter, we are allowed to use concentration. We are allowed to use concentration ratios. When an acid or a base dissociates, you are allowed to use concentration ratio, which means since I do have the concentration of the MgOH, it is 0,0608. Then I can do the ratio there. The ratio is 1:1:2. I want to try and find the concentration of OH because I want to be able to get to that. So the ratio is 1:2, which means the concentration of OH, it's going to be 0,0608 times 2, and that gives me 0,1216. That is my concentration for the hydroxide ions, mole per dm minus 3. But remember also, I am looking for pH, and pH requires hydronium, not hydroxide, but we do have a formula that allows us to convert from hydronium concentration, from hydroxide concentration to hydronium, the Kw, the ionization of water. Then I'm going to say concentration of sorry, the 3 is supposed to be at the bottom here. The concentration of the hydronium ions is going to be 1,00 times 10 to the power negative 4 divided by the concentration of OH is that one, 0,1216. Then I'm gonna get H3O plus to be, so 1 times 10 to the power negative 14 divided by 0,1216, 0,1216, and I get 8,2. I'm just going to keep 4 decimals, 37 times 10 to the power negative 40. That's the concentration mole per dm minus 3. And now I'm able to find the pH. pH is minus log H3O plus concentration, which is minus log, and there I have 8,2237 times 10 to the power negative 14, and that gave me minus log of the answer, minus log. That gives me 13,08, and that is my pH. And remember, I said at the beginning we expect the pH to be basic. We expect it to be basic because we have an excess base, so a pH of 13,08, it is basic, and that is our final answer. So that is how we approach the question on acids and bases calculations. Just know what is going to be on your products. Just to remember, we said since we are reacting magnesium hydroxide with HNO3 and they say this is in excess, if it is in excess, it means at the end of the reaction, in the reaction vessel, we will have some of this. That's why they want the pH, because you need to find how much of this are we going to have. So this whole calculation that I was doing here, I was trying to work out the excess magnesium hydroxide. Then from that, I'm able to dissociate it because they said it's soluble. Then I do concentration ratios. We are allowed to use concentration ratios there only on dissociations of acids and bases, dissociations and ionizations. Then from there, you can do the calculation. I hope it makes sense, guys. Please do let me know if you would like for me to do more questions like this one. I will definitely do that. Thank you so much. Bye-bye.